Welcome to this video. My name is Mark Scythian. The date today is October 27th, 2024. And so this video is going to focus on mass, gravity, and weight in both the US and metric systems of measure. And most are familiar that in the metric system, force weight is equal to mass times gravity. So mass is the number of atoms and molecules of any substance independent of gravity. So that's constant throughout the universe. But when mass multiplies itself times a certain gravitational acceleration, then it is converted into force weight. So most are familiar with this that are in any type of physics program or studying physics, etc., making any technical calculations that understand that. But many have kind of lost track of or not been introduced or reintroduced to the concept of absolute mass in the U.S. system of measure. So it's assumed all that the United States has is pounds mass or pounds force, etc. But actually that's not true, because the Old English and U.S. system operated, at least in all their calculations in the glory days of engineering, like in the 50s and 60s, 40s, post-World War II, World War II, they used the Slugs absolute mass value, and one slug is equal to 32.2 pounds because it's taken right directly out of the gravitational acceleration. So make a example here is that if you had 150 pounds mass individual and you divided it into 32.2, that person would have an absolute mass of 4.66 slugs. And then if you multiplied that value of mass in the US system times 32.2, you would then yield the 150 pounds of force. So there is a correlation in the US system of measure with respect to mg for force weight, and that is the slug's mass times the gravity in 32.2 feet per second squared, then to yield pounds force. Okay, so that's really how absolute certainty is reached with respect to mass, gravity, and weight in the US system of measure. But however, if you were dealing with the metric system, you would right away convert the 150 pounds mass into kilograms by dividing it into 2.2. And then you would get, let's say, 68.18 kilograms, then times 9.81 to yield 668.85 newtons of force weight. And then the second step would be to divide it into 4.45, the number of newtons force per 1 pound force, and then you would reach the 150 once again. And so you can actually use the slugs absolute mass metric in the US Old English system of measure and have the same result. And the only time that this becomes less accurate is when you get into subatomic displacement and range calculations, or subatomic lengths and distance measurements and etc. So that's where 1 divided into the speed of light, the light second inverse, that's the metric value of the meter. So that's where absolute certainty for distance was attained when that occurred in the quantum physics realm right around the 1905 to 1920s. So this is kind of a strata coming out of Maxwell field equations from the 1800s into the Einsteinian era, and then we reach the absolute distance metric of the meter, 3.28 feet. And the Old English and U.S. system of measure is pretty close, yard, 3 feet to a yard, and the absolute distance is 3.28 or 1 meter. So then you could scale that down. I don't know if you'd have nano yards or milli yards or micro yards. I mean, it could have ended up like that, for subatomic displacements, distances, lengths, range, propagation, position, etc. You could have had the Planck's constant in micro yards or 10. So you could have ended up like that, but you go just a little more accuracy to certainty, you end up with 3.28 feet to a meter. And so the yard unit and most everything for atomic and subatomic physics, quantum physics, in measuring energy, then went to the metric system, and that's where you will always win in the calculations. But it's not to say that, hey, how come we have force weight is m times g, and we know that's kilograms times gravity in the metric system, but how come we can't apply that in the US system? I mean, I can't take pounds and multiply it times 32.2. That will come out to something that's doesn't make any sense. However, yes, you can, as long as you convert the pounds into slugs. So the absolute mass unit in the US system is a slug, or 32.2 pounds. And then if you multiply it times 32.2, then you get the force weight in pounds force. So that's something to keep mindful of. And again, pounds force versus pounds mass. And so that pounds mass, 2.2 pounds mass is 1 kilogram. But when pounds mass multiplies itself times gravity, it then becomes pounds force with respect to, let's say, weight. We're not talking about dynamic force where you push something, but we're talking just about mass, gravity, and weight. So the absolute mass in the US system is not pounds mass, it's actually slugs mass, then multiply times 32.2 feet per second squared to get pounds force. Just like in the metric system, you multiply kilograms mass times 9.81 meters per second squared, and then you get newtons force. And so it's assumed you have to do it that way and then reverse the newtons force into pounds force by dividing it into 4.45, which you can do. But in the US system of measure, it's often overlooked that the absolute mass unit is actually the slug. One slug mass is equal to 32.2 pounds. And so you have to convert that, then multiply it times gravity in the US system of measure, 32.2 feet per second squared, and then you get the pounds force. So just wanted to mention that, and there were some very astute viewers and students that made that point and said, hey, how come we get mg but we can only do it in the metric system? Well, we can do it in the US system provided we use the slugs mass absolute. We use the absolute mass of slugs rather than pounds mass. So if you use slugs mass times 32.2 feet per second, then you get pounds force. And again, just to repeat this again, and then if we compare this to mg in the metric system, it is kilograms mass times 9.81 meters per second squared, for which most everybody who's taken a physics class understand that. But to correlate that into the US system of measure, we take the slugs mass and then multiply it times 32.2, then we get pounds force. So the main takeaway is that you can use this as a guide in case that you have a hybridized equation that is including slugs, degrees, rank, and absolute temperature. For example, that's Fahrenheit plus 460, whereas absolute temperature in Kelvin is degrees Celsius plus 273. And so there may be quite a lot of equations that are hybridized as you start to integrate different systems. You may run into that, and then you run into these errors that you know how to do the problem, but you've kind of lost track of the conversion factors, especially the absolute mass in the US system. And then you look up the symbols and you say, oh, that's a slug, it's a 32.2. And they're not really big into teaching that anymore, but it's in some of your coursework. So just the final takeaway is that force weight is mass times gravity. That is true. And in the metric system, it's kilograms times 9.81 meters per second squared. But in the US system, it's slugs times 32.2 feet per second squared. And so that brings forth absolute certainty in both the US and metric systems of measure with respect to mass, gravity, and weight. So thank you for watching this video, and have a great day.